proof process is, and you'll kind of see the difference. Well, there's not really an example, but you'll see how 2-column proofs look versus a paragraph proof, which we're going to do Monday, is exactly what it sounds like. It's just a proof in a paragraph. But proofs, whenever we complete proofs, we use theorems and postulates. That's what's in your packet. There's definitions, there's theorems, there's postulates. So theorems are statements that can be proven, just so you understand why some are called theorems and some are called postulates, what that difference is. So a theorem is something that has been proven, versus when we talked about postulates in 2.6, or no, 2.5, postulates are statements that are just accepted as true. So they're accepted as true without proving them, such as a line goes through 2 points. That's just accepted as fact. It's not proven. It's just accepted. So here's the 2-column proof process, and I will for sure be stressing these steps as we go through problems. The first step is, if a diagram is not given to you, draw a picture. In the past, working with students on proofs, that's the biggest thing, is it's really hard to go through a proof if you aren't visually looking at something. So draw a picture, or if a picture is given to you, label the picture. Understand the given information, and also understand what you need to prove. So don't just jump right into the proof, look at exactly what am I given, and then what am I trying to prove, so that you can work towards that goal in your head. Like I already said, mark your picture. And then we'll talk about this as we go through them. It says look for freebies. So freebies would be when you look at your picture, look to see, are there any vertical angles you can pick out? Are there any shared sides or shared angles of objects? But we'll talk about that more as we get into these, because we're going to be doing proofs, like I said, in chapters 3, 4, and 5 also. Step 6, work out the proof in your head, which reasoning backwards can help in that case. And then you're writing out the proof. You'll have statements in one column, reasons in the other column. So you're justifying each statement with a reason, and your reasons are from that properties packet. So it's either a definition, it's an algebraic property, or it's a theorem or a postulate. Just like we were justifying those steps for the algebraic proofs. So then I did want to share with you, when we write paragraph proofs, these are sentences, so full sentences in the form of a paragraph explaining why the conclusion is true. So each sentence would cite a reason justifying why it's true. And so these reasons can be definitions, algebraic properties, theorems, or postulates. Basically what is stated up here in step 7. So the reasons you would put in a 2-column proof, really the only difference is, rather than having 2 separate columns, you're writing out every line in your 2-column proof as a sentence. That's really the only difference when we'll do paragraph proofs. The proofs for today and tomorrow, though, will look like this. So you'll have all of the statements in the first column, so that's kind of like as you're working through it. Just like in the algebraic proofs, it was the steps of solving the equations, and then you have your reasons off to the side why each one is true. And then I also have on here working backwards. So one method for writing a proof is to work backwards. So start with what you're trying to prove, work backwards step by step until you reach the given information. Honestly, we'll go through examples. You'll see me work through these with you. It's going to be practice on your part also. So it's not just us going through this in class. To really understand proofs, you just have to practice a lot of them. That is the best way to get better at them. With most things in math, the best way to get better at it is to practice it. So they do get easier, or that's the goal, that they will get easier the more that you do. But if you're really struggling through the first 2, or you're just really struggling today, that's normal. Think of it as like a productive struggle. You have to struggle through it to start, and then as you get going, the goal is that it gets easier. So we're going to start out, we'll go through an example of a proof. Now, these we've kind of helped you out because if you look at the two columns, some of the statements and the reasons are already filled in. You're just filling in the blanks. So it's not like you're starting from scratch, or I'm expecting you to start from scratch where everything's blank. You have to come up with all of the statements, all of the reasons. So you do have some hints in there to help you out. You're just filling in what isn't already filled in for you. But if we look at number 1, so we are given that the measure of segment BC is equal to the measure of segment DE. We are trying to prove that AB plus DE is equal to AC. So there is a diagram already given to you. If I were to mark this with what I'm given, I know in this diagram BC and DE are the same measure. So I'm just going to put a line marking on here so I know they're congruent. Okay, and then there's what you're trying to show. And if you look at the picture to reason through it, you're trying to show that AB plus this segment DE is equal to this whole segment AC. So how we get to that, we always start with, or I guess it doesn't have to be the first statement, but a lot of the time it will be. BC equals DE, that's what we were given. So that reason would be given. So what you're given should always be somewhere in your proof. Normally it's at the beginning, but it doesn't have to be. Then notice the second statement is blank. The reason is filled in that we're going to be using the segment addition postulate. And you can look at that to help you. But this is what I tell students when they're working through proofs is look at your diagram and if nothing else, just state something that you know. So when I look at this diagram, my first thought, because I'm trying to prove that two segments added together equals another segment, but when I look at my picture, I can say right off the bat that with this segment, AB plus BC should equal AC. Okay, I know I can say that by the segment addition postulate. So that's the reason I'm going to put here is that AB plus BC is equal to AC. So if nothing else, try something, and if it ends up not working out reasoning-wise, erase it, try something different. But if nothing else, look at your diagram and say, okay, what can I say about this? And see if that helps you. But now, notice the last statement's already filled in, which is what we were trying to prove, that AB plus DE equals AC. So if you look at line 2, and then look at line 3, while also looking at what you're given, anybody know the reason for number 3, why we can now just jump to AB plus DE equals AC? Any ideas? Look at line 1. Look at line 2. How can you use lines 1 and line 2 to get line 3? Yeah, because BC and DE are congruent. All that's happening, these are congruent, so the BC here is being replaced with DE. What property says we're allowed to do that? I think I heard somebody say it. Symmetric? Not symmetric. It does start with an S. Substitution. Okay, so all you're doing there is then substituting DE in for BC. And we have what we were trying to prove, so we're done. Okay, any questions on number 1? Okay. So here's another one, number 2. We are given actually 3 different things. So we are given that Q, and there is a diagram also. Point Q is in between points P and R. We are also given that point R is between points Q and S. And then we're also given that PR is equal to QS. So I'm going to mark this on my picture. You just have to be careful with how you mark it. So if I do this PR and then QS, I I know those are equal, they're congruent. All right, so again, some of these statements and reasons are filled in. Use that to help you, but also reference your diagram when needed. So we're starting out. This one, the given actually isn't all stated at once. It's stated in 3 different steps. I think it's, 3 different steps it's stated. So for number 1, I have Q is between P and R. That was part of what I was given. So that reason is given. Then, similar to what we did in number 1, when you're looking at this diagram, they're saying then PQ plus QR is equal to PR. So what reason allows us to say that? Not substitution, if that's what I heard. So what allows us to say PQ plus QR equals PR? Segment addition postulates. And you'll notice with proofs too, you're always kind of looking at things you've already stated and saying, how can I use what I've stated to help me in my next steps? So now in step 3, they're saying R is between Q and S. That was also given to us. So that third reason is also given. So normally you might see all 3 things given all in one statement. You might see it broken up into 3 different statements. So then number 4, they're not giving us the statement, but we have the reason is segment addition again. So here if we're told R is between Q and S, anybody know what statement we can say here if we kind of follow what happened in steps 1 and 2? QR plus RS equals QS. Yes, we can say QR plus RS equals QS. You will notice repetition as you go through more proofs. Like I said, the idea is the first few might take a while, and then it hopefully will get easier to understand these. So now we have PR equals QS. This was also given. That's the third given. So 5 is also given. And now look at what they have for 6. So we have PQ plus QR equals QR plus RS. Anyone know what allows us to say that? I'll kind of show you, I'll highlight some things here. I just maybe want a different color also. So we have, because again, you're always, or chances are you're using the lines that are above. We have that PR is equal to QS. That's what we said in line 5, and then we jump to line 6. If you look back at lines 2 and 4, 2 is saying that PQ plus QR is equal to PR. Notice in line 6, rather than having PR on the left side, they put PQ and QR. That's from line 2. And then in line 4, they said QR plus RS was equal to QS. So in place of QS, they put QR plus RS. So they substituted for line 6. Substitution is used quite a bit. So if you even wanted to draw arrows so you know things to look for, substitution is always something to look for. This one in place of PR, this one in place of QS. Okay, so then in line 7, they have PQ plus QR minus QR equals QR plus RS minus QR. So they're taking line 6, all that is changed for line 7 is the minus QR on both sides. It's not identity of addition. It's the subtraction property of equality. because you are subtracting the same quantity from both sides. So now take line 7 to get what we're trying to prove in line 8. If you look at line 7, I mean, really what you're trying to prove should be your last statement. Okay, but if you look at this, on both sides, I'm going to have QR minus QR. Those will cancel out. And you are just left with PQ is equal to RS. And then the reason's already there, subtraction fact. The reason it's not the identity of addition is because it's being subtracted. So it's just a fact that if I take QR and subtract QR, it's going to cancel out. But that reason's already filled in. Okay, questions on that? So, like I said, the only way for these to really kind of sink in is to practice a bunch, which is what your assignment's going to be. These last 3, though, these are just one-step proofs to remind you of a few reasons. So for 3, if you are given that segment DE is congruent to segment GH, what reason allows you to conclude that then segment GH is congruent to segment DE? Kelly? That is the symmetric property. So if you just switch the two sides of your congruency statement or your equal sign, if it was an equal sign, if just the two sides are switched, it's symmetric. For 4, if you're given segment AB is congruent to segment RS and segment RS is congruent to segment WY, what allows you to conclude that segment AB is congruent to segment WY? Artessa? That is the transitive property. So if you have two quantities that are equal to the same thing, they must be equal to each other. That's transitive. What about the last one? AB is equal to EF plus FG. BC is equal to EF plus FG. Therefore, AB is equal to BC. Any ideas on that one? It's actually the same thing, transitive. Okay, just looks different, but notice AB and BC are both equal to the same thing. Therefore, they must be equal to each other. So that is also transitive.